This topic is non-right-angled trigonometry. So when solving non-right-angled triangle problems, you need to make sure your triangle is labelled correctly. So when we label a triangle with a non-right-angled trig, more often than not, the angles are represented with capital letters and the sides are represented with lowercase letters. Now you see here how where I've got capital A, the angle there, lowercase a is the side opposite. So that's always the case. Then if we look at B, angle B is at the top, lowercase b is the side opposite, and you'll see it's the same with angle C and side C. So always the lowercase letter is the opposite side to the capital angle. Now when we're working out the area of a non-right-angled triangle, quite often we don't know the height. So our usual half base times height doesn't work because we don't have the height of the triangle. But we can use a different formula. And this formula is the area equals half AB sine C. So what that means is that we know A and B, which are two sides of the triangle, and C is the angle between them. So as you can see in this triangle diagram here, we know two sides A and B, and then angle C is between the two sides that we know. If we don't know that, we can't work it out. It has to be the included angle. We'll just do a quick example. So find the area of this triangle. So we look at our two sides, 11 and 15. We need to ask ourselves, is the angle between those two sides? Yes, it is. 28 is, which means we can use a formula. So the area will equal a half times by the sides times 11 times by 15 times by sine 28. Put that straight into your calculator and you will get 38.7 centimetres squared. Now I've rounded that to 3 significant figures because I believe that's a really good habit to get into. And that's it for finding the area of a triangle. Now our next rule on this topic is the sine rule. So in any triangle ABC with sides lowercase ABC and opposite angles of capitals ABC, we have these rules. Now these two rules are exactly the same, it just depends on what you're trying to find out. So for me personally, if I am trying to find an angle, I'll use the first form. If I'm trying to find a side, I'll use the second form, but it doesn't really matter. What this represents is that we have the sine of angle A divided by side A equals sine B over B equals sine C over C. So in a triangle, the ratios between the angles and the sides are the same. Now to use the sine rule, you need one of the following: two angles on one side or two sides and a non-included angle. And we'll do a few examples. So this first one, we want to find x rounded to 3 significant figures. So our x is a side, so because I'm trying to find a side, I'm going to put that on the top. So we'll have x on sine. Now the angle is the angle opposite the side. So opposite x is 113, so it's sine 113. That will equal the other side, which is 18, divided by the angle opposite the 18, which is 41. So sine of 41. From here I can rearrange. So to get rid of the divide by sine 113, I can multiply that to the other side. So I'll get 18 multiplied by sine 113 divided by sine 41. So this is why I like to put my unknown on the numerator of the fraction, because it means the rearranging is just easier. Put that straight into your calculator and we'll get the x is equal to 25.3 meters to 3 significant figures. Example 2. So we've got this triangle ABC. We know that AB equals 12, AC equals 8, and angle B measures 28 degrees. We want to find angle C. Now, I haven't been given a diagram, so best thing we can do first is to draw a diagram. So just draw a triangle. We're going to label it A, B, and C. Now we know from A to B it's 12 centimetres. AC is 8 centimetres. And angle B measures 28 degrees. So from here, I can now use my sine rule. So I'm trying to find an angle, so that's what's going to go on top, and I'm trying to find angle C. So we'll have sine C over the side opposite C, which is 12, equals sine of B, which is 28, divided by the side opposite angle B, which is 8. Rearrange. So we'll have sine C equals 12 sine 28 on 8. Now remember, we want to find the angle, so we need to do our inverse, so the sine -1 of 12 sine 28 over 8. And if you put that in your calculator, you will find it is 44.8 degrees. Now, one thing you have to be aware of with the sine rule is that because we haven't been given a diagram, this angle C could be an acute angle or it could be an obtuse angle. Because triangle, we can draw the triangles two different ways. So we've got this one here, but it could have also been drawn like this, where this angle C here is bigger than 90 degrees. We don't know which version of this triangle it is, and this only happens with the sine rule. So we always have to then be aware that this could happen, and we need to counter for that in our answer. So the answer could be 44.8 degrees, or it could be 180 minus 44.8 degrees, which is 135.2 degrees. So there are two possible solutions to this problem. Now, once again, this only happens with the sine rule and if we have two sides and one angle. It's the only time we can have an ambiguous case. All right, example 3. In triangle KLM, angle LKM measures 52 degrees, LM is 158 meters, KM is 128 meters. Find the size of the angle. So once again, let's draw a triangle and label it. So KLM. Now we know K to M is 128 meters and L to M is 158. And LKM, which is angle K, is 52. Now once again, we only have one angle and two sides, which means there will be an ambiguous case for this triangle as well. So we want to find the size of angle L. So we'll have sine L divided by 128, the side opposite, equals sine 52 divided by the side opposite the angle, which is 158. Do our rearranging. So sine L will equal 128 times sine 52 over 158, and so then L will equal sine -1 of that as well. And then you just need to put that straight into your calculator and you'll get an answer of 39.7 degrees. Now we know it could be acute or obtuse, so we need to find our other angle that it could possibly be, which would be 180 minus 39.7, which equals 140.3 degrees. Now, we can actually reject this answer. And the reason for that is if we look at the angle we've already been given, which is the 52 degrees here, I'm just going to circle it. If we did 140.3 plus 52, we get an angle which is greater than 180, which is impossible because a triangle has to have three angles that add up to 180. So 140.3 plus 52 is greater than 180. Therefore, we can reject. It's impossible to have a triangle with those angles. So for this one, the only possible solution is 39.7. And our last rule in trigonometry is the cosine rule. So to use the cosine rule, you need either two sides and the included angle, or all three sides. Now, our rule for the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. Or if you're finding the angle, you can use the rearranged version, which is cos a equals b squared plus c squared minus a squared all over 2bc. Now, the main thing here is obviously you're going to have different letters at different times that you're trying to find. So as long as the a squared and the cos a, those two letters are the same because they're the opposite side and angle, then the ones in the middle should all be good. All right, so I always just check those ones first. Let's have a look at examples. So find the length of BC correct to two decimal places. So I'm just going to call that small a because it's opposite angle A. And we're trying to find the side, so we can use the first rule. So a squared equals b squared plus c squared minus 2bc cos a. And just put our values in. So we're trying to find a, so a squared equals b squared 12 squared plus c squared, which is 10 squared, minus 2 times by 12 times by 10 times cos, and the angle is 38. So work that out, you get A will equal 54.877419, etc. So that's what A squared, and then we've got to square root that, so we get A equal approximately 7.41 meters. Example 2, we want to find the angle now. We want to find angle C. So we can use the find an angle version of the formula. So we'll have cos C equals, and it'll be A squared plus B squared minus C squared divided by 2AB. So this is where you've got to make sure your letters are in the right space. Now the cos of C will equal A squared, which is 12 squared plus B squared, 14 squared minus C squared, which is 11, all divided by 2 times A and B, which is 12 and 14. Then, because it's finding an angle, we need to do the inverse of the cos -1 of all of that, which would be 219 over 336, and that gives us approximately 49.3 degrees. So the main difficulty people have, or the main issues people get into, is that they don't put their numbers in the correct spot. Some problem solving, and then we will be done with trigonometry. This example, we've got a triangular property is bounded by 2 roads and a long straight drain. We want to find the area of the property in hectares, then the length of the drain boundary. So we want the area of the property, which means we need our area formula, which remember is half AB sine C. So we know this 120 angle, so I'm going to label that C. And then A and B can be either of the other angles. Now we just sub everything in. So a half A times B, so 277 times 324 times sine of the angle, which is 120. Now remember, for this formula, the two sides have to be either side of the angle you're using. Work that out, we'll get 38,862 meters squared. Now the question was in hectares. If you didn't know, 1 hectare is equal to 10,000 meters squared. So this would be approximately 3.89 hectares rounded to 3 significant figures. Now I want the length of the drain boundary. We look at to find side C. Do we know 2 sides and the included angle? Yes, we do, which means it must be the cosine rule. So it'd be C squared equals A squared plus B squared minus 2 times by A times by B times by cos of the angle. Put that in your calculator and you'll find that C squared equals 271453. Then square root that to find what C is, and C would be 521 meters. Next example, a ship sails 58 kilometers on a bearing of 72 degrees once it has passed a reef. It turns and sails 41 kilometers on the bearing of 158 degrees. How far is the ship from its starting point? So bringing some bearings back in, because you never know, they could turn up in an IB. And I know how much you love them, so we probably need a bit of practice. So we need to draw a diagram. So a ship sails 58 kilometers on a bearing of 72 degrees. So remember, it always starts from north. And 72 degrees will be in here somewhere. And they go for 58 kilometers on an angle of 72 degrees. Once it gets to a reef, it turns and sails 41 kilometers on a bearing of 158 degrees. So we're due north here at the reef. And 158 degrees will be on an angle down here, and it goes for 41 kilometers. And that's on an angle of 158 degrees. Now we want how far is the ship from its starting point, so we are wanting to know what is this distance here that I've dotted in black. So the first thing that we need to work out is, to work out this side, we've got 2 sides. We're going to look at what angle can we find out, and we can actually find out this angle in here, which means we can then use the cosine rule. Now to find that angle, we need to think about what this angle here would be, that I'm drawing in orange. Now remember, when we have two straight lines like this, these angles in between add up to 180 degrees. So we know that this is 72, which means this one must be 108 for it to add up to 180 degrees. Now we've worked out the 108, we can work out the black angle, which would be 360 minus 108 minus 158, which will give us 94 degrees. Now we've worked out that, we can use our cosine rule. So x squared equals 50x squared plus 41 squared minus 2 times 58 times 41 times cos of 94. That means x squared equals 5,376.76. Take the square root of that and you get 73.3 kilometres. So once again, the hardest part of this question is actually working out the angle. Just a few little rules you have to remember, like that co-interior rule there. That one comes up quite often with bearings in helping you find out other angles. And then that is the end of our non-right angle trigonometry.